All right, so the first thing that we need to do to understand the Dozenal version of pi is to understand the difference between the base 10 and base 12 versions of the Cartesian plane. So on the board behind me here, I have a 1 by 1 square, and it's divided into tenths or decimals. So we have decimal places, and just for your own interest, the word decimal, DEC, is a derivative of dividing into tenths. So we have words like a decade or a decathlon, got that DEC in there, so that implies dividing into tenths. So we have decimal places, and we're on the base 10 Cartesian plane. So we're dividing our 1 by 1 square into tenths. And you can see here I've drawn a line across here that is the length of 1, 2, 3, 4, 5 units of square root of 2. So that's 0.5 root 2 is the length of that line. So up here, 0.5 root 2, and that 0.5 is 5 tenths. So if this was the complete line of the square root of 2, all the way from one end of that corner to the other, this is 5 tenths of that line. Okay, so now we're going to go over here and look at the base 12 version of the Cartesian plane. So now we're looking at Dozenal points. So we've divided that same size square initially into twelfths instead of tenths. So those are different sized units. They're a little bit smaller. So I've drawn a line here again, 0.5 root 2 on the Dozenal Cartesian plane. So again, 1, 2, 3, 4, 5 little squares that make up that line. So that's 0.5 root 2. It looks the same, that number when I write it out looks the same, but actually from a base 10 standpoint, it's a length of 5 twelfths. So 5 twelfths root 2. So we can see that it's actually a smaller length, because when we divide something into twelfths, these little individual squares are smaller than the little individual squares here. 1/10 is a larger unit than 1/12. So that's the first thing we need to realize, that we're working with smaller sized units when we're working on the base 12 Cartesian plane as opposed to the base 10 Cartesian plane.